Okay, welcome to Chapter 24, Network Operations, page 431. So basically we're talking about building, operating, and maintaining the network. Okay, so there's an awful lot of IP-enabled devices now. I mean, things you would think about, like PCs and phones, but there's other things. Lighting systems, even thermostats. So maybe you didn't really anticipate that when you were designing your system. Like, I don't know, 10 years ago, having a IP addresses for your thermostats was probably not something anyone thought about, right? So no one ran an Ethernet cable next to where the thermostat was connected, right? Nobody did that. So what is the number of drops, network drops at a desk? Well, to tell you the truth, the answer right this very second is 2. 2 drops, one for the PC and one for an IP-enabled phone. But to tell you the truth, that's probably wrong. It probably needs to be 3. Have a spare, because quite frankly, we just don't know what IP-enabled devices are going to show up on a desk next year. We don't know that, okay? And it just kind of makes sense when the contractor comes in to just tell them, hey, I want 3 drops for every cube in the cube farm, or 3 drops in every office, okay? That just kind of makes sense. Okay, on page 431, they talk about monitoring. So monitoring is all part of the operations point. You're supposed to be checking to make sure that you're not abusing a subnet, so to speak. Or so one link in the network is always going to be the weak link in the chain, right? You can't make the weak link go away. You can move it around, but there's always going to be a weak link somewhere. So as at the bare bones minimum, the things you need to be collecting is, like for network devices, you need to check the health of the device. So I have a switch or a router, and the number of resources that are being consumed, okay? Like how much memory is left on this thing, or how many. For network links between devices, it ought to be the health and resources and the error rate. How many errors are being kicked out? Obviously, one of the things you probably want to do beyond just the minimum is the throughput. How many connections are happening? How many ports are live, and how many of them are talking, and what's the total bandwidth coming out of the device? Because, every switch, let's say I have a switch that has 24 ports. Each one of them is capable of doing 100 megabit, okay? Got me? So am I, coming out of the back end of that thing, am I going to have 24 times 100? Coming out the back? Probably not, because they built these things assuming that not every single one of the ports is going to be blasting 100% at all times. So, by the way, keep that in mind when you're building a data center, because data centers are not like that. Data centers is, yes, I fully anticipate every single one of these guys to be consuming practically all the bandwidth at all times. Okay, but anyway, so knowing where the bandwidth limit is, probably like on the back of the switch, yeah. I mean, if I have a gig E coming off the back and 10 and 100 coming off the front, then logically, getting more than 10 people talking simultaneously, I'm going to overload the switch. Okay, another thing you need to be monitoring is whenever you have a redundant link, you need to know when that redundant link kicked in. In other words, when a failure occurred. Now, clearly, there's no immediate impact. Like people are not, maybe not even notice, maybe a tiny bit of slowdown. But you need to jump into action to go figure out why. Did it burp? It's just no big deal. Reboot the guy, or is there some sort of a problem? You had to replace it. So it's all about detecting problems, predicting their failure, or predicting the end of life, or predicting when that needs to be replaced because of the amount of bandwidth, and then preventing that thing. So detect, predict, and prevent. By the way, I've said this before, but anytime that the users think you're psychic and can find out a problem before it shows up and solve the problem before they know it, that's a good thing, okay? Being psychic, or pretending to be psychic, is probably a good thing. So management on page 432. So management is not the same thing as monitoring. We're really talking about controlling the configuration. So I've got a Cisco router, and I tweak it from time to time, and I probably need to be writing all this stuff down, having some sort of recording Okay, last Tuesday I went in and I changed this from 20 to 25 as a test to see if that was going to help. And so now I record, how the throughput is. And I go, ooh, that didn't help any. Let me take it back down. Instead of 20, I'll use 15. You need to be recording all that. Okay, so access and audit is what it's called. Basically, whenever I make a change to a network device like a router, I really basically need to generate an audit trail that Bob, on the 22nd, did this, okay? The who and the when are kind of sort of easy, but that part's easy. Who did it and when they did it, that's kind of easy. But why? That's going to have human intervention, right? Somebody's going to say, well, I was changing this to see because we had a latency problem, and I thought maybe changing this value from 20 to 25 might help. And we ran it for a week and it didn't. That's useful information. By the way, highly skilled people are going to be tweaking Cisco routers, right? Nod your head. You know what I'm talking about, right? You don't take the junior guy and say, hey, here's the password for the router. Why don't you go in there and make this change? Really? Okay. So, what's the typical life cycle of a network appliance like a router? Well, the average life of a router is about 5 years. If you bought a good one to begin with, okay? If you bought an El Cheapo, well, no. Because, capacity planning is all... Whenever you do capacity planning, you're not going to get it right, okay? I'm just telling you. You say, wow, we have 100 users on this floor, so therefore I only need 2 of these switches. And then 6 weeks later, you merge with another company and there's 300 people on the floor, and you go, geez, I never anticipated that. How in the heck am I going to do this? Okay, life happens, all right? So you're never gonna get the capacity planning right. Never, ever. So you need to be able to figure out, do I buy good stuff and put a lot of them in there, perhaps some redundancy, that kind of stuff, so that it'll last longer? 5 years is not a long time, particularly since PCs are about 3 years life cycle. So here's a bad problem with life cycle replacement. So let's say that a router died. It's 5 years old and it's time for me to swap it out. There's really kind of sort of not really a way to test the new one in a non-production environment. Not really. I mean, you can kind of sort of fake it over here, but to tell you the truth, routers are such an integral part of the network that you almost no way to test them in a real life scenario other than plugging them into the network. I know that sucks. So a lot of people skip the test environment or have a very minimal test environment and go directly to production. So once again, it's just going to have to be right. Okay, there's a bullet list on page 434 talking about, where like a device is. So let me just go through the list. So in stock, which means it's sitting in a cardboard box in a warehouse. Okay. Assigned, which means, okay, I've picked it out and it's going to go in this location. Installed, which means I've taken it out of the cardboard box, plugged it in to the 19-inch rack, but I haven't turned it on yet. Deploying is, okay, I've turned it on and I've done some initial configuration. Operational means we're using it now, okay. Servicing means I have to temporarily take it down because I need a firmware update. Decommissioning, which means I'm taking it down and probably taking it out of the rack. And then dispose of, which is wiping it completely. Demilitarization is a cool term. And then removing it from inventory and something. By the way, in the Army days, if you wanted to take out your frustration, you would demill a piece of equipment, because one of the things we would do is we would wipe these hard drives. And then just to make sure there was no way anyone could ever recover them, we take them out and, beat them with a sledgehammer or take a drill and drill holes through it. So if you really wanted to take out your frustrations, you could by taking a sledgehammer to a couple hard drives. It was very helpful. Okay, so that's kind of their little technique of keeping track of all the devices. So should I use the latest and greatest cabling technology? What is the latest and greatest thing? It looks like 6A, which will get you 5 gigabit or 10 gigabit, okay? But there's actually a 7 and a 7A and an 8.1 and 8.2. What are those guys? Well, that is a copper connection, but that's not designed for the intermediate frame kind of guy. It's not designed hooking a PC. That's for a short connection, less than 30 meters, between one server and another server, or one switch and another switch, okay? It's not designed for the things we're talking about. So 6A currently, right at the time of this taping, 6A is probably what you ought to go for, and you probably ought to go for 3 drops per office area, cube, farm, whatever it is you got. So Cat 7 and Cat 8, no. I mean, you might use it inside the server room, but not outside the server room. Okay, so configuration management on page 435. Based upon a template, basically, when I set up my Cisco router, I have a checklist of all the things I want to do. I want to track the changes to the configuration, and there's some really cool software. I love this one, called Rancid. I love it. Really awesome new Cisco config differ. I know. Hey, they probably had a contest of who can name this thing. Rancid. And what it basically does, it runs an audit. It's a little script that goes to your Cisco router, records all the thing, and then compares it to what you did and says, aha, this has changed. Okay? That's kind of cool. So, I like that. So, software versions. So, firmware and software updates. Yes, almost all these are going to have, security-related firmware updates. Yeah. And once again, you probably ought to take the small batch approach. Let's say you have 15 Cisco routers, the exact same model. I would probably want to take one at a time. And I would probably take the least important section and do it first. Like I wouldn't start in the server room. And, do the firmware patch, do the security patch, whatever it is, and make sure it worked. Give it time for it to kind of do its thing. And then maybe next week do the other one. Okay, now I'll confess, if there's an urgent security issue where, oh my God, these things have to be patched immediately, I still would do it as slow as possible. So, can you test a patch in a lab environment? Well, I could pull the thing out and take it to a lab and make sure it doesn't puke. But that's about it. I mean, really, okay, the firmware didn't crash the machine, but as far as testing in a real, how's it going to respond in the real world? Man, that just doesn't work. So, by the way, you can use that monitoring software to see like how many routers have not yet been patched. That would be kind of cool. Okay, documentation on page 437. So this is obviously documentation is designed to help you with troubleshooting, right? And explain what things are supposed to look like, and most importantly, why it's supposed to look like that. So there's basically 4 types of documentation. Network design, DNS, domain name system is actually kind of sort of documentation. That database thing we keep talking about in labeling. So the first one is like the network design and implementation, the logical and physical diagrams. Quite frankly, I had access to, an engineering plotter, that plots on paper that's 3 foot wide on a roll of paper. It could be like 100 feet long if you wanted it to. So we would produce these 3 foot by 4 foot diagrams of our network and, posted on the wall inside the server room. So we would have a constant reminder of, okay, this is the router that connects to there. And, and this link is a gig E link. And this link over here is, the redundant one is only 100. Those kind of, so all sorts of annotations on there. The logical and physical diagrams, the bandwidth, the latency, all those things. And again, Visio has a really cool template, if you're ever into Visio, on how to build a network diagram. I mean, they have some excellent ones. You could use that. You can have, there's a lot of free software out there that can build network diagrams for you. Kind of cool. Anyway, I printed a gargantuan one, hung it on the wall. I kind of like that. DNS, so domain name system, is the thing, you guys know what DNS is. Hopefully you've been to a network course where, it's sort of like the phone book where, I look up a name, it tells me what the number is. But that could have some logical things to it. And so I know all the devices and I know what all their IP addresses is. So if you print out, the DNS thing, you can kind of sort of figure out, where everything is and what their names are. Because here's what will happen. You check your inventory. I've got 12 items on my inventory. You go to the DNS and I got 13 items. And you go, well, what am I missing? Holy heck, what is that? Well, it's a printer sitting in some closet someplace you didn't even know about. Okay, we're coming up on the 15-minute mark.